So, good morning, all. Today we are going to discuss one of the important topic in database management system, that is transaction processing. So, my introduction is this is P. Kalyan Chakravarthy, working as assistant professor in CSC, AML, and CS department and GUIDE. So, we'll be looking over what are the topics or the outline, what we are going to discuss in the next coming slide. So, before uh, coming to the outline, I would like to tell you that the transaction processing generally deals with the transactions and their properties. So before going to that transaction processing and the outline, I would like to inform you that Unified Payment Interface, which is implemented by Narendra Damodar Das Modi, who is the Prime Minister of India, with his noble vision towards India's development, almost like the last year, it is 89.6 billion transactions have been done by our country, India, and we stand top in the world. So this particular transactions being handled by the UPI, Unified Payment Interface, which is developed by India. So under the visionary leadership of Narendra Modi, so we reached to the top position. So it is a proud moment for all the Indians. And before going to this topic, just for the general knowledge sake, I have introduced this unified payment interface concept. And this unified payment interface concept has many transactions. So as I told you that 89.6 billion transactions. So each and every transaction will be having a properties. So we'll be discussing the outline. That is the transaction definition, an example of transaction, properties of transaction. So properties of transaction are ACID. We generally refer to ACID. So A stands for atomicity, C stands for consistency, I stands for isolation, D stands for durability, and followed by the transaction states. So this is the outline of the current topic. So now coming to the first slide, that is transaction definition. So various textbooks or various sources, they give different definitions for transaction. So we'll discuss all the transaction definitions here. So the first definition says that the transaction is a set of operations used to perform a single logical unit of work. So we'll see what are the set of operations and what do you mean by single logical unit of work. And second, the transaction is a unit of program execution that accesses and possibly updates various data items. So what is data items? So how they are updated and what are the set of operations that are performed on it. So we'll be discussing it later. And the third definition of transaction is it's a logical unit of database processing that includes one or more access operations. So these operations, which we generally referred in the first definition, that is set of operations. So read, write, so insert, update, delete, retrieval. So all these comes under set of operations that are performed on the data items. Okay. So next, the transaction. This is a bit technical definition. So a transaction is a set of operations, may be a standalone, specified in a high-level language like SQL, submitted interactively, or may be embedded within an application program. So this is a bit technical definition, which you can write for transaction definition. And finally, the last one, the transaction refers to a small unit of any given program that is divided into various low-level tasks. So we'll see what are these tasks or set of operations which we are considering it as program execution in the coming slide. So coming to the example of transaction, here we are considering a small example, like example of transaction, that is we are trying to transfer $150 from account A to account B. So here the data items are account A and account B. So here you can see that the data items are account A and account B. The initial amount may be any amount, but we are trying to transfer $150 from account A to account B. So this particular transaction, this particular total block, we call it as single logical unit. But in this single logical unit, we are having set of operations. So what are the operations? The first one, so read of A. So you're trying to read the account A and you're trying to subtract or debit. So general terms, or you can use whatever the terms that you specify for that operation. So you can reduce 150 rupees from account A and you're going to update it. So that is the right operation that you're going to perform on account A. So once the account A, the read and write operations and updation is done, Next, you are going to take the account B. So you're trying to read the B, and that 150 that is debited from account A must be credited to account B. So here you can see this operation that the $150 are credited to account B, and finally you're trying to write B, which is updation. So here these are the set of operations, and this total bulk of operations together we call it as single logical unit. So it has some logic in it, that is transferring 150 amount from account A to account B. So now coming to the set of operations. So what are the operations? That is read. In order to access a particular account, we call that as read. And then coming to the second operation, that is write. So if you want to perform any changes, then we go with this write operation. And subtract and addition, we generally call it as debit credit. And finally, whatever the changes that you want to do, that is what we call it as update. And finally, when the transaction or the logical unit is completed, we commit, which is permanently storing the data. And there are other options, that is rollback and save point, depending on the transaction failure, or in between the set of operations. If a transaction fails, what is the status that we have to generate? So based on these particular categories, we understand that these are the set of operations. So I hope every operation is clear. So now coming to the properties of transaction, here I said that this is ACID properties, ACID. So A stands for atomicity, C stands for consistency, I stands for isolation, and D stands for durability. Before going to the properties, I would like to share the rightmost part of the slide. That is, if you want to perform the atomicity property in a transaction, then who is going to take care of the roles and responsibilities of a particular designation, right? So here we can say that it is transaction manager. So transaction manager will be taking care of the atomicity property of a transaction. Now coming to consistency, the application programmer will be taking care in writing the logics for providing consistency in a transaction. In the same way, isolation property will be dealt with concurrency control manager. So, and finally durability will be dealt with the recovery manager. So these are the possible designations in which these properties are being used in the transaction. So these designations or these managers will be taking care of the particular transaction to make it a valid one. Right, now coming to the first property, that is atomicity. So here you can see either all operations of the transaction are properly reflected in the database or none of them. So here uh, so that comes under atomicity. That is, the transaction has to be 100% complete or 0% complete. So this particular property we call that as atomicity, and this property has to be there in the transaction. And coming to the consistency. So coming to the second property, that is consistency. So this is the first property, and this is second property. This is the first property, and this is the second property, that is consistency. So execution of a transaction in isolation preserves the consistency of the database. So we'll see with an example how the consistency of a database or a transaction do exist. And the third one is isolation. So isolation, here you can see that multiple transactions may execute concurrently. Each transaction must be unaware of other concurrently executing transactions. So intermediate transaction results must be hidden from other concurrently executed transaction. So here he has taken an example, like there are two transactions like TI and TJ. So here TI may have some set of operations and TJ may have set of operations with that of data items or the accounts that are involved in the transaction. And now if the TJ, then that either TJ finished execution before TI started. So TJ has to complete its execution before TI, or TJ started execution after TI. So parallelly, we cannot execute TI and TJ if the data items are in parallel in both the transactions. So that we have to consider in isolation. So each and every transaction, irrespective of the data items that are shared among the two transactions, other than that, this particular property, if it holds good, then we call it as isolation property. And finally, the durability. So if the transaction completes successfully, then the changes has to be permanent in the database. That is why we call that as database persistent. Even if the system crashes or internet problem or hardware problem or software problem, so whatever the problems that comes in near future, this particular durability property will make the entire transaction to be permanently stored. So generally the commit operation will help in this durability property. So here you can see that atomicity either none or all. So 0% or 100%. Next, coming to it states that all the operations of the transaction takes place at once. If not, the transaction is aborted. So using this rollback and save point, using these two transaction control languages commands, you can make use of this atomicity property. And now there is no midway, that is a transaction cannot occur partially. So this is the most important point to be noted, that the transaction cannot occur partially. It has to be complete or it has to be incomplete. So each transaction is treated as one unit and either run to completion or it is not executed at all. So these are the two important properties which comes under atomicity, that is 0% or 100%. Now atomicity involves two operations, as I told you, that abort and commit. So abort is if any of the particular set of operations in between, if there is a failure in hardware or software or system is crashed, so whatever may happen, you have to use the support option to redo or roll back to the initial position, right, and commit. So all the transaction, if it is committed, these changes are permanent and it is persistent forever and it is visible to all the users anytime. So this is all about the atomicity property. We'll go to the consistency property later. So here coming to the second property, that is consistency. Here we generally refer to as integrity constraints. So these are the constraints that are applied on the data to make it a valid data or a complete data. So this database is a consistent before and after the transaction. So the consistency holds good only if the changes that are made to the database before transaction or after transaction, the data has to be common. We'll see with an example. Before that, we'll see the properties of the consistency, right? The execution of the transaction will leave database in either prior stable state or a new stable state. And then the consistency property of the database states that every transaction sees a consistent database instance. So instance is at a particular moment of time, what is the data that is available in the database. So that holds the consistency property, and then the transaction is used to transform database from one consistent state to another consistent state. Now by looking at these definitions, you will understand this example. Now I'm considering a particular transaction. In that transaction, two transactions are there, T1 and T2, where the the transaction is like account A to account B. So in the account A, almost like we'll go with an example in the coming slide. Before that, there is something like before the transaction and after the transaction, the account A and account B, there will be initial amount, and after the transfer also the amount has to be same. We'll see with the example in the coming slide, so that you will better understand what is the consistency property. So here with this example, you can understand that account A is having 500 and account B is having 200. So now this particular account A, which is having 500, and the account B that is having 200, now the transaction is you have to transfer 100 from account A to account B. So this is how a particular set of operations are done for this operation. So first you are trying to read A. So read A, and then you'll get the amount as 500, and then you are going to subtract 100 from account A, and you are trying to update the account A. So finally the amount of A will be 400. Now in the same way, you try to read the account B, which is 200, and you are trying to add 100 to it, and you are trying to update the account B, that is 300. So after that you commit it. So this particular full transaction will be totally completed. And after this particular transaction, you can see the amount in account A is 400, the amount in account B is 300. So this is a general way of understanding how the transaction looks like with a set of operations. But what do you mean by consistency is, here you can see that is before transaction, the account A is having 500 and account B is having 200. And after the transaction, the account A is having 400 and the account B is having 300. So if you add these two, before transaction and after transaction, the amount remains the same. So hope you understood that this example is better suited for consistency. So when commit is executed, and if you check before the transaction and after the transaction, the amount remains the same, then this particular thing we call that as consistent data. So this is what we call it as consistency property. For example, the second, we'll take the second case, that is inconsistency data. So here also account A is having 500, account B is having 200, but now after the transaction account A 400 is there, but in between there is a failure here. So there is a failure here, the system is crashed, and after that if you compare, the amount after transaction and before transaction varies. So before transaction it was 700 and after transaction it was 600, so there is a loss of 100 which is not in account A and not in account B. So this leads to inconsistency. So I hope this is a better example for you to understand the property of consistency in a transaction. So I hope this would make a huge difference in analyzing or understanding the consistency property in the transaction. So coming to the isolation property, which is the third property in transaction. So here you can see that isolation, so it shows the data which is used at the time of execution of the transaction cannot be used by the second transaction until the first one is completed. So you are trying to isolate two particular transactions where this particular transactions has to be isolated because the data items or the set of operations that are performed must be isolated with each other. So parallelly or concurrently, if the transaction make use of the same data item, it leads to inconsistent state. So that is the reason why this isolation property plays a very important role. So the second line says that in isolation, transaction T1 is being executed and using the data item X. So here we are using the data item X in the transaction T1. So then the data item can't be accessed by the transaction T2, which means that they will perform some locks on that particular data item X, which means like some bank account, account A or account B, like that here the account is X. So if you perform that lock, then the other transaction cannot make use of this data. So like that you have to perform this particular property. So the concurrency control subsystem of DBMS will be enforcing this isolation property. Here you can check that read A and write B, and after that read A and read B. So here you can see this transaction T1 leads to T2. So here this is precedence graph. So precedence graph, it is consistent state. Since T1 leads to T2, there is no cycle or loop formation in this particular example. But here if you say this read A and read B, and here the account in transaction T2 is read, and now you're trying to perform the write operation, but it is already used by T2. So and then write A and again write A. So you can see here that T1 transaction leads to T2 and T2 to T1 and T1 to T2. So here you can see that there is a cycle, right? So T1, T2 and T1. So whenever there is a cycle, then it leads to the inconsistent state. It leads to the inconsistent state. Now T1, T2, it leads to a consistent state. So I hope the isolation property is clear, right? So this is the fourth property, that is durability, which is the last property in ACID. So durability property is used to indicate the performance of the database consistent state. So it states that the transaction mates are permanently recorded or permanently changes are recorded. They cannot be lost by enormous operation errors, or as I told you, software or hardware, whatever may be the errors or the system failures, but the data has to be permanently recorded. So whenever the transaction is completed, then the database reaches to the state which is a consistent state, which is most important, and that consistent state cannot be lost even if the event of the system failure. So this consistent state has to be protected. So this is what we call it as durability. And now the recovery subsystem of the DBMS has a responsibility of durability property. So this particular recovery management is important in durability. So whenever in future a particular transaction, if it is completed, you should be in a position to look or visualize that particular transaction. So this property holds good when the system is in consistent state. So here another definition of transaction states, it is another concept where here you can see that the transaction states are active, partially committed, failed, aborted, and then committed. So under aborted, there are two possible options, that is restart the transaction or kill the transaction. That is 0% or 100%. So this is the diagram to understand the transaction states. So by this, we have concluded all the basic properties of a transaction, that is atomicity, consistency, isolation, and durability. So I hope the session is interesting, and thank you for your patient listening. Thank you.